Imagine this. You're floating 250 miles above Earth. The silence is absolute. You turn to look at the space station, and it's drifting away, faster than you can swim, faster than you can call for help. In seconds, it's just a glint of metal in an ocean of black. You are alone in space. What happens next? The moment an astronaut becomes untethered in open space, the clock starts, and it's unforgiving. In the vacuum of space, there's no air resistance, no friction, nothing to slow you down or change your direction. If you're drifting, you keep drifting forever, unless something stops you. But astronauts aren't completely helpless. Every spacewalking astronaut today wears a device called SAFER, the Simplified Aid for EVA Rescue. It's essentially a small jetpack built into the suit. It fires tiny nitrogen thrusters, giving the astronaut just enough control to maneuver back to the station. The catch? SAFER has a limited fuel supply. You get one shot. Panic, waste fuel, overshoot, and that opportunity disappears. Now consider the suit, because it's the only thing standing between you and one of the most hostile environments in the universe. Space isn't just empty, it's extreme. Temperatures can swing from 250 degrees Fahrenheit in direct sunlight to minus 250 in shadow. There's no breathable air. Cosmic radiation moves through you without warning. And without the suit's pressurization, the fluids in your body would begin to vaporize. A modern spacesuit carries roughly 6 to 8 hours of oxygen. That's your window. If you can't make it back, those hours tick down with ruthless precision. The helmet visor shields you from micrometeoroids and blinding solar radiation. Multiple suit layers protect against punctures but sudden depressurization. You're not just wearing protective clothing, you're wearing a personal spacecraft. But it was never designed for drifting endlessly into the void. Back on Earth, and aboard the station, the moment something goes wrong, it's noticed. Telemetry from the suit continuously transmits position, oxygen levels, and vital signs. Flight directors respond immediately. Emergency procedures are activated. Trajectories are calculated in real time. The station itself can maneuver. Thrusters can reposition it to attempt a rescue. But orbital mechanics is unforgiving. Both astronaut and station are moving at nearly 17,500 miles per hour around Earth. A separation of only a few feet can expand into hundreds in minutes. The window for rescue is painfully narrow. And then there's the math. In orbit, everything follows strict physical laws. The station and the astronaut are both falling around Earth. If you drift ahead of the station, you drop into a slightly lower orbit and paradoxically begin moving faster. If you drift behind it, you rise slightly and begin moving slower, increasing the distance between you. To catch something in front of you, you often have to slow down first. To close a gap, you may need to fire thrusters in a direction that feels completely wrong. It's counterintuitive, and in a moment of panic, misunderstanding that physics could mean drifting farther away with every pulse of fuel. Astronauts train relentlessly for this. The SAFER unit includes a small display to help orient movement. Procedures are rehearsed repeatedly in simulations. But applying those lessons when you are truly alone, watching your only way home shrink against the blackness, is an entirely different challenge. Remarkably, no astronaut has ever been lost in open space, but there have been terrifying close calls. In 1965, cosmonaut Alexei Leonov became the first human to walk in space. His suit overinflated in the vacuum, becoming too rigid for him to re-enter his spacecraft. With oxygen running low, he bled air from his suit, a dangerous, desperate measure, just to squeeze back through the hatch. In 2013, Astronaut Luca Parmitano's helmet began filling with water during a spacewalk, nearly drowning him hundreds of miles above Earth. He navigated back almost blind. He survived, but only just. Every spacewalk is a negotiation with risk. The truth is, space doesn't hate you. It's simply indifferent. It doesn't recognize bravery. It doesn't bend for experience. It follows its own laws, absolute and unchanging. Surviving out there means understanding those laws completely and respecting them every second. Every astronaut who exits an airlock knows the danger, and they step into the void anyway. Because some frontiers are worth the risk. Some discoveries are worth the silence. And sometimes, reaching beyond the world that made us is the most human thing we can do.